Got a speed racer, he's a demon on wheels. He's a demon and he's gonna be chasing after someone. He's gaining on you, so you better look alive. He's busy revving up the powerful Mach 5. And when the odds are against him and there's dangerous work to do, bet your life's speed racer to see it through. Go speed racer, go speed racer, go speed racer, go. He's on the fly as he guns a car.
All right. Good morning. Today's lesson is about cheesy 60s cartoons. No, it's about speed. And how do we calculate speed? I thought, what better way to start it than a little speed racer cartoon? Okay, so today, if you have a calculator, go grab one. Or if you have a pencil and paper, we can do some calculations here. Today, we're going to go through a few problems about speed. And then I have a little quick Google form for you to practice some speed problems, 10 questions. I'll post that on Classroom after the video. All right, so let's get started here today. If you have a pencil, paper, or calculator as well, pause the video and go grab one. Here we go. Excuse me. Speed equals distance over time. That's the formula that we're going to use today. So when we talk about motion, speed is the easiest formula to start with because number one, we're all familiar with it, and number two, it's a simple division problem. So speed equals distance over time is the formula we're going to be using. If you want to shorten that, you can write S equals D over T. And remember back to density when we did that. If you think back to that problem or that formula, density equals mass over volume. So a similar type thing here today, except we're dealing now more with the physics side of things and the topic of motion. Here's a little speed triangle or pyramid that you could draw if you want to. You have distance on the top and speed on the left and time on the right. And you can actually see all the different formulas in here. So if you want to calculate speed, basically put your hand over speed, and then what you're left with is seeing distance divided, that line there, over, or distance over time. So if you take, cover speed up here, and then distance over time is how you calculate speed. If we want to calculate distance, cover distance up with your hand. And if you look at the next or the two remaining blocks, you have speed and time next to each other. So it'd be speed times time. So distance equals speed times time. And then time, if you cover time up, you can see that time equals distance over speed. So those are some easy kind of, ways to remember the formulas. Draw that little distance pyramid if you want something to keep in your notebook. Remember, once again, we're just continuing your learning here about science, and we're talking about motion here. So don't get too stressed out if you don't understand all this. Just give it a shot, okay? I know you can do it. So let's practice some speed problems here. If you want to write down in your notebook speed problems, we're going to use this formula, speed equals distance over time, to begin with. So that's where we're going to start on these problems. Number one, if an elephant walks for 2 hours and travels 8 miles, what is its average speed? Average speed basically means if you take from start to finish, you know he's going to go a little faster or a little slower, but overall, what is his average speed? So what we do is we find the distance and we find the time, because once again, speed equals distance over time. So our distance here is 8 miles, and make sure to keep the units with it. So it's 8 miles, and our time is 2 hours. Excuse me. So remember, time can be measured in hours, it can be measured in minutes, seconds, it can be measured in days, weeks, months, years, centuries, millennia. All right, so however we measure time, that's what we put on or we put that unit with the number. So for example, this first one I started off with units we're familiar with, miles as the distance and time in hours. Okay? So elephant goes bye-bye, math replaces elephant. We have 8 miles divided by 2 hours, and we get 4 miles per hour. Once again, we took 8 miles as the distance because speed equals distance over time. And then we took time as 2 hours. So 8 miles divided by 2 hours equals 4 miles per hour. Let's go back to that formula here. So speed equals distance over time. Our distance in that last problem was 8 miles, and our time was 2 hours, and our speed was 4 miles per hour. Okay, how are we doing so far? Let's try number 2 here. What is the average speed of a vehicle that covers 250 miles in 2.5 hours? So this one, we have to find our distance, which is 250 miles, and our time, which is 2.5 hours. Now, in order to calculate this, we'll need a little trick where we take the half and convert it to a decimal, the fraction. 1 over 2 needs to be converted into a decimal. So what we get is 250 miles divided by 2.5 hours. So take 250 on your calculator, divide it by 2.5, and you get 100. So some of these you can do in your head, but I'd always double check with some kind of calculator just to make sure we don't misunderstand the math inside of our head. Okay, so that little trick there, we had to take the half and convert it to 0.5. And that way we can easily do the division problem. So once again, speed equals distance over time. Okay, number 3. Let's take this formula, speed equals distance over time, and let's talk about a person walking. If you walk with a speed of 2 meters per second, how far do you walk in 12 seconds? Okay, so I'm looking at this and I'm thinking, where is my distance? Do I have a distance on here? No. I have a speed on there, which is 2 meters per second, and I have a time on there, which is 12 seconds. So if we go back to our formula, we already have a speed and we have a distance, but we need to get a time. Okay, sorry, take that back. We have a speed and we have a time. We need to get a distance. So we can go back to that speed pyramid here. And if we look here, we have a couple different formulas we can use. Speed equals distance over time, we were using. Distance equals speed times time. All right. Or time equals distance divided by speed. So let's see the 2 variables out of the 3 that we have here. We have a speed and we have a time. So what we're going to do is we're going to use distance equals speed times time. All right, because we're looking at how far we want to walk. Or we could also use good old common sense. Sometimes in physics, just go back to good old common sense here to figure out these speed problems. Check this out. If you walk with a speed of 2 meters per second, how far do you walk in 12 seconds? Well, you know what? If I'm going 2 meters per second, after 1 second, I've gone 2 meters. That's what it says, 2 meters every second. After 2 seconds, I've gone 4 meters. And after 3 seconds, I've gone 6 meters. Continue that process out, and after 12 seconds, you go 24 meters. So that's kind of the common sense way to look at it, right? Every second, you're going 2 meters, 2, 4, 6, 8, 10, etc. Or you can use the formula where you go distance equals speed times time. So we'd have the speed of 2, the time of 12, and we'd get a distance of 24 meters. Okay, so once again, look at your possibilities here. Speed equals distance divided by time. Distance equals speed times time, and time equals distance divided by speed. Okay, at this point here, you're probably like, all right, Mr. Creek, I'm done listening to the math today. I don't know how much more of this I can take. Well, hang with it, okay? This These speed problems are getting your brain to think about the natural world in a mathematical way. That's something to think about here. Remember, our topic's motion, and no matter what it is, from the Earth's plates to the moon orbiting the Earth to people running on a track, all these things can be charted with math. So that's our goal here. Use math to understand the natural world. Okay, so just think back to our intro question, what is motion? And if we think about that, and we think how these people have tried to chart these things, like all these natural phenomena, and observe these things, well, guess what? We have some math to figure that out. We have this thing called speed, where we can try to calculate the speed of a bird flying, okay, or the speed of fish swimming. We just take their distance traveled and divide it by the time. So just think of the big picture here before we move on to these next problems. Okay, I'm going to let you guys do these problems here, and then I'll show you what we came up with. Here's Bob. He can throw a baseball a distance of 48 meters